In section 2.6, we'll start talking about what it means for a function to be continuous. In the simplest terms, what it means for a function to be continuous over an interval is that you can trace your graph from left to right without having to pick up your pencil. The second you have to pick up your pencil to continue tracing is where you are not continuous. And then if you can continue after that, then that would be part of your interval in which you are continuous. But anytime you have to pick up your pencil to continue tracing your graph is where you are not continuous. And that cannot be included in your interval. So let's take a look at a couple of examples of things that can happen that can make your graph not continuous. Well, if you take a look at this first graph, you have an issue. If you were trying to trace the graph from left to right, you'd have an issue here at 2 because you'd have to pick up your pencil at 2 in order to continue tracing. So what you would do is to trace this graph, you would start on the left-hand side where the arrow is and continue up to 2. That means if you were writing this out as an interval, you would go from negative infinity up to 2. Now the idea is you cannot include 2. It doesn't have anything to do with the fact that there's an open circle there. It's because you have to pick up your pencil at 2. So that means you are not continuous at 2, so you can't include that in your interval. So we'll put a parentheses there. Then you can continue tracing on the other side at 2 and continue on forever. However, so we can go from 2 and continue on forever towards infinity. However, again, the idea is at actually 2, you do have to pick up your pencil, so you cannot include 2. That's why we're going to use parentheses. Even though you see a closed circle, it does not matter. You had to pick up your pencil at 2, so 2 can't be included. So you have to use the open parentheses on either side. Then we need to put these two pieces together, and we'll put them together with a union, a U for union. So that means we are continuous on the interval from negative infinity to 2 and from 2 to infinity, but notice because of the open parentheses here at 2, we are purposefully leaving 2 out of that because that's where you pick up your pencil. Let's try another one. In the next one, we're tracing from left to right again. We're going to go all the way up towards 2 again. So we'll go from negative infinity up to 2. Notice because of the asymptote here at 2, we do have to pick up our pencil. So we're going to put parentheses at 2 again because you're picking your pencil up at 2. You can get closer and closer to 2, but you can never actually touch it. And then we can also trace the other side after 2, continue on forever. So that would be from 2 to infinity. Again, open parentheses at 2 because you're picking your pencil up at 2. And we'll do a little U. As a reminder, though, this thing in the middle, this dotted line, means that you're never going to touch 2. You'll get closer and closer and closer, but you'll never actually touch it. There's a special name for this. It's called an asymptote, as a reminder, and we're going to see these over and over again throughout the course. In the next one, we'll again trace our graph from left to right, starting on one end and working our way up. Notice you have an issue here at 3 because there's no point at 3. There's an open circle, meaning I actually can trace all the way up from negative infinity up to 3, but because there's no point here at 3, I technically have to pick up my pencil because I can't touch 3, and then I can continue after it, but I can't include 3 because there's no point there. So I am going to have to use an open parentheses again, and then I can pick up after 3, after the open hole, and continue on forever. And then I need to put a U in the middle to put together those two pieces, and that is when our graph is continuous, and that is called a whole linear graph. Now what we want to do is continue on looking at some more problems and seeing when they are continuous. Let's take a look at A in the first set of examples. So starting on the left side and working your way from left to right, if you trace the graph, notice you never actually have to pick up your pencil, and the graph continues on forever in both directions. So this particular one, when is it continuous? It's continuous from negative infinity towards positive infinity. You never had to pick up your pencil. On this next one in B, we're going to start at the left-hand side, working our way up. And it's continuous until our graph stops. Well, it continues from negative infinity to our point. Notice our point has two values, a 0 and a -1. Which one do I use? Remember, you're tracing the graph from left to right, which means you're using x values. So I'm only going to use the x value, which is a 0. Notice I don't need to pick up my pencil at 0. You can continue all the way up to 0, so I'm going to use a bracket at 0, and that's okay. So my graph is continuous all the way from negative infinity up to 0 and including 0. Next one, let's take a look. We're tracing our graph from left to right up till the point, but there's an open circle there at the point, so I cannot include that. So that means I can trace from negative infinity on the left all the way up to the point. Be careful. I'm tracing from left to right, so I'm only going to use the x value on the point, which is an x value of 1. So I can trace all the way up to 1, but I can't include 1 because there's a hole there, so I'll use an open parentheses because I can't include 1. Then I can trace everything after that open hole all the way to infinity. Again, that hole started at 1, so that's where I'm going to start my other end. I can't include 1 because there's a hole there, so use an open parentheses again, and we'll combine the two with a union symbol. So what this says is I can trace anything before 1, anything after 1, but at 1, we're not including that because you had to pick up your pencil just for a second because there's no graph at 1 because of the hole there. You can't ignore any holes in your graph. Let's take a look at D. In D, tracing your graph from left to right, notice that you can trace all the way up to your asymptote at -2, but you can't actually touch your asymptote -2, so you'll have to pick up your pencil at -2. So I can trace from negative infinity up to -2, though. Can't touch the asymptote, so I'm going to leave that as an open parentheses. Then on the other side, I can trace from the -2 without touching it all the way on to infinity. So I'll start up from -2 all the way up to infinity. Again, I can't touch the -2, so I'm going to pick up after -2. So I'll use an open parentheses again, and I'll use a U to connect those two pieces, and that is when I'm going to be continuous. Anything before -2 and anything after -2, and again, it's because I cannot touch this asymptote, and I have to pick up my pencil here because of it. I've got an asymptote there.